Welcome to SPSS PSY 3840. I'm Professor Coolidge. We are going to learn today the chi-square test. So all these other tests, we've assumed normal distributions of the data. We can analyze it with a mean and a standard deviation. It makes sense because of the nature of the dependent variable. But in a chi-square test, we do not have that assumption of either a normal distribution or a continuous variable that we're analyzing. So the chi-square test, we call this a non-parametric statistic as opposed to these parametric statistics we've been dealing with. Parametric meaning we can use the standard mean and standard deviation. Non-parametric means a mean and standard deviation don't make any sense. For example, in medical studies a lot, you'll have an outcome. The person either lived or died. It was successful or not successful. It's not a continuous variable. And what you're going to have is people, generally, who fall into a frequency, and that is, what's the frequency? How many people lived? How many people died? When you're just doing a number frequency, that's going to be analyzed by this chi-square test. So let's go into Unit 14 to the chi-square test lecture. We're going to use only one design here, and that's going to be the most popular design, a 2x2 chi-square. What we're going to do here is we're going to look at two different types of treatments. So you might consider this one independent variable. The two types of treatment for coronary heart disease, atherectomy and balloon angioplasty. Atherectomy, actually, you go in and you kind of roto-rooter out the plaque. And balloon angioplasty is you break the plaque up with a little balloon that's inserted in the artery. So one independent variable is the coronary heart disease treatment, either atherectomy or balloon angioplasty. The other independent variable is outcome. You either lived or died. Our dependent variable, if you like, is going to be more like the outcome, the frequency. So what we're going to do is know if you had an atherectomy, how many people lived. If you had an atherectomy, how many people died. So the frequencies of that interaction in that 2x2 design, those frequencies are going to be like our dependent variable, and that's why we're going to analyze it with the chi-square test. And I'll show you how to conduct and interpret the chi-square test. So let us open up. We're going to do a new data set so I can show you how to enter this, because SPSS makes it a little tricky. So let's go in and open our data set, a new data set, and I'll show you how we'll enter the data in our book. And we're going to use the problem in the book in chapter 14, or in chapter 15, I'm sorry. In chapter 15 on page 352 and 353, and that's going to be problem number 12 through 15. And we're going to determine whether a different type of heart surgery, a new type of heart surgery, is better than the old type of heart surgery in terms of patient outcome. So this is going to be part of our lesson, is just learning how to insert this data for a chi-square and SPSS. So one of the, in a 2x2 chi-square, one of our factors with two levels is going to be the type of surgery. So we'll say surgery, and that's going to be either an atherectomy. Let's go over to values, and we'll say either the atherectomy, which is like a roto-rooter. They stick a little roto-rooter in the vein or artery, and then they get out the plaque by removing it with a tiny little tool. So we'll say add, then we'll put in 2, and this will be the typical common balloon angioplasty, where they stick a balloon in and then break up the plaque. So angioplasty, and we'll add. Okay, so now we've got our two levels. One's going to be an atherectomy, two's going to be the patients who got an angioplasty. We hit OK. We're going to go over here. We only need one level. We need no decimals and only one width. So our variable width, because it's either going to be a 1 or a 2. Our second variable in the 2x2 is going to be outcome. And this is frequent. This outcome is kind of frequent in, especially in medical research, but also in therapy. I mean, if it's relatively dichotomous outcome, like you either get better or you don't. So we'll go over here, Now in this case, since it's medical, we got 1, and it means you lived after a year. You're still alive after the procedure. And 2, unfortunately, you're dead after the procedure after 1 year. Okay. And then, in a way, our dependent variable is the frequency. What do we observe for each of these 4 cells? In a 2x2, there's going to be 4 cells. So this is frequency, Q-U-E-N-C-Y. And here, we'll actually need since our frequencies are observed to be at least a width of 3 whole numbers, then we're going to have to make our width 3 here. And so now, and we don't need a value here because it is the frequency, it's the outcome frequency. So we'll go back to data view. Okay, so we had one group who got atherectomy and lived, one group, let's do 1 and then 1, 2, 2. Okay, so, and the outcome is, okay, so this is, they got atherectomy and they lived. They had an atherectomy and they died. They got balloon angioplasty and they lived, a 1. They got balloon angioplasty and they died, a 2. So notice we've got 4 different groups. We've got a group, a cell that is 1, 1, a cell that is 1, 2, a cell that is 2, 1, and a cell that is 2, 2. So these are the people who got atherectomy, and the outcome was they lived. And if we look in the book at the bottom of page 352, we see 495 patients alive after an atherectomy. How many patients died after an atherectomy is on page 353, and that is 17. How many got balloon angioplasty and they lived? 503. And how many got balloon angioplasty and they died? And that's on the top of page 353, and that says there were 9 patients. Okay, we're ready to run a chi-square, except SPSS, in its own tricky manner, says go to data and go to weight cases. And what are we going to weight cases by? We're going to weight the cases by this dependent variable frequency, our non-parametric dependent variable, by the way. Weight cases by frequency, and we'll click it over here. Then we'll say OK. And we've got some old output here, so I'll get rid of that output. So we'll have brand new output. And so we'll go to Analyze. One way we can do this chi-square is through these crosstabs right here. And in a row, we could have either surgery or outcome. In a column, we could have the other. Okay, statistics, we'll order the chi-square statistic right here. Here in cells, we can get the observed cell frequency. If you'll look in the book in chapter 15, you can read about how to get what observed means, what expected means. We can get percentages for columns and rows, which are kind of useful, actually. And so we'll put expected here just because it's in the book also. Okay, and then we'll go to continue, and then we'll go to OK. So this is our chi-square, and here's what's happening. What we see is, and let's just interpret what's happening here. This atherectomy, we've got 3.3% of the sample who died, that's the 17, and 96.7% who are still alive. So is atherectomy a safe procedure just descriptively? Yeah, it looks like it. Okay, is it any more safe or unsafe than angioplasty? Well, only 1.8% of those with angioplasty died. And so we see almost a double the rate increase in terms of frequency of those who died, but 98.2% are still alive. So what we're really testing is this increase one way to look at it. Is this increase in morbidity associated with atherectomy, is it seemingly greater than this increase? And that's what that 2 by 2 chi-square is telling us. And right down here, we go down to the Pearson chi-square statistic. Here's the value of the chi-square. It's 2.526. And here is the two-tailed test of significance. And we can see it is not significant. So what this says is that this rate of increase, in fact, if we even divided 3.3 by 1.8, we could get the rate of increased death of an atherectomy to angioplasty. But what we see is that increase is not a significant increase. We might have sufficient power here with 1,024 people. And in fact, this will also be subject to abuse of power. If we increased it, significantly, like 5,000 patients, 10,000 patients, we might get a significant difference. But at this level of 1,000 patients that we've randomly assigned to get either atherectomy or angioplasty, this is not a significant increase according to this chi-square. Notice down here, a chi-square does have an assumption that none of these 4 cells, here's really the 4 cells, 495, 17, 503, none of these cells are less than 5. And indeed, we don't have any cells less than 5. And that's our chi-square lesson for today.